of AI. Our next speaker, Yash, who's an avid football player and a Formula One fan. Unfortunately, he supports the people I don't support in Formula One, so I shall not talk much about that. But Yash, over to you to talk about MCP.
Hello, everyone. So, I'm Yash. I'm currently working as a backend and platform engineer at FlankSource, where we are building a Kubernetes native IDP. And today, I'm going to be talking about building MCP servers in Go. So, I've been hearing this word a lot, and I'm sure you are as well. MCP. Every time I open Hacker News, MCP this, MCP that. But what's up with that? Why do we even need MCP? Well, as Gautam said, the age of AI is upon us. We are at the crossroads of a new era, and MCP is kind of heralding us there. So why do we need it? Well, in short, it allows AI, as in LLMs, to perform real-world actions, and it also helps autonomous agents. Uh, Sorry, it also helps MCP LLM run autonomous agents, and accidentally, it has somehow become a new way to discover and expose RPCs of your system. But what is MCP in the first place? Well, it stands for Model Context Protocol, and as with the word protocol, it's a specification. So it is basically the specification of how an LLM and a normal application would interact. And Anthropic, the creators of Claude, started this in 2024, but somehow it has now become the industry standard for this. So MCP has three things. One is host, client, and server. We'll discuss all of these in detail, but in short, host has multiple clients. Clients, as you know, call the server. Server does some stuff, and then they return data to the client. How they work in congestion, how do they all work together? So yes. If you look at the diagram, so the host and client are usually packaged together. So, and each client maintains a one-to-one connection with the server. So if you see the client one calls the internet, so the MCP server could be hosted anywhere. And then client two and client three, they're talking to your local binary applications that might be running on your computer. And how does the actual transport happen? How does it call locally or externally? Well, so there are two ways to do that. So it uses JSON RPC2. And then when you're talking to local binaries, it's standard input-output. And when it's HTTP resource, there has a streamable HTTP transport. How does it actually look? So it's a pretty simple JSON message. So you have JSON RPC, and then you have method. We'll discuss the methods later. And then in params, you just give data. It has name and arguments, and then the server decides what it will do with that data. And so it has three building blocks, three primitives, if you say, resources, tools, and prompts. Let's go a bit into detail. So resources are just data. They can be your files, they can be your API calls, they can be your database calls, it can be anything. They are URI based, and yeah, I think our best way is to look at the example. So in the first example, we want my passport. So you will just send this URI to the MCP server, and the server should know how to parse this and then find the file in the file system. Let's say you are a normal company and you have a user database, and then if you want to get any specific user, so you'll just call user and whatever the username. So you can templatize it, and it is static as well. Then the tools are where the actual magic happens. You can imagine them just as function calls. They are the things that do the real world tasks. They have their own JSON schema. And then if you look at the examples, they basically make changes outside the ecosystem. So in the first example, we are updating the replica count. So I'll pass the name of the VM and I'll put the count we want. And then the MCP server will know that this tool is called and it will decide what to do. Similarly, if you're searching for flights, you'll tell your source, destination, and some computation will happen we don't care about right now. The LLM doesn't. It's just as a server, it should handle that. And lastly, we have prompts. So prompts are basically templates where the MCP server will tell the LLM that this is the prompt you use. So let's say if I have to plan a vacation, I'll write a huge prompt that I'm planning a vacation, and then I'll take some arguments from the user. And then in return, I'll generate a huge text, send it back to the LLM. And then the LLM will use, and yeah, it's basically one way for server authors to tell users how to best use uh, their server. And okay, so just a small comparison, what is used and when that is used. So tools are for AI actions, and the LLM decides when to use what tool. Then resources, they're just static contextual data. The client, the host, decides when a particular resource needs to be used. And prompts, well, if you use an MCP server, you can use whatever prompt you want. So enough theory. I'm pretty sure no one just wanted to read the spec. So let's build our own server. So in this talk, we'll be talking about the Mark III Labs MCP package. The official MCP Golang SDK is still in beta, so I wouldn't recommend using it yet. And to create your server, it's pretty simple. You give it the name, you give it a version, and then there are some other parameters that you can give. Then, so right now, what we want to do is create a file system MCP, and it should do one thing, which is create files. So in this, we are creating a tool called create file. Descriptions are important because then the model can tell that if I want to do this specific thing, I have to call this. And then when we are creating file, we need two things, the path and what content goes inside the file. And then lastly, we have which function handles it. And the handling is pretty straightforward. You take the path, you take the content, and then this is normal logic that you can write. You create a directory if it's required, and then you write content to that file path. So it's time for a demo now, because it's better if you look at these things. Okay. Is the text visible to everyone? Okay. This could be a internet issue, but I was in SRE before, so I have prepared a backup in case. So I actually did a recording of what I was going to present. So yeah. Okay, so we are running Cloud Code. And now what I want to do is create a file, and if you see, I am not telling it the exact path. I want it to tell that this is the directory. The file should be readme.txt, and inside the content should be hey. And now it will think what to do. And then it asks me, okay, do you want me to call this function? And then you can say yes, call this function with this data. And it says it's created. So now let us check in the temp directory if something is there. Okay, so there is a readme.txt. And is it correct? Yes. So that is one simple way to do things. Let's take a bit of a different example. So now, what are prompts? So before I go there, Uh, Let me show you how a prompt looks. So in the create n file prompt, I just like wanted to confuse the LLM. So I've asked it that this is the prompt that will go to the LLM. So I'm asking it that I want you to create n files where n is the user input, and then the file names should be user1, user2, user3 till n, and inside that write hello n times. So if you are the user, oh, we have Claude running, but okay, I'll just continue with the screencast for this one. So if you are a user, you will use the create file prompt, and I gave 8 as the argument, so I wanted to create 8 files. Uh, it will think something, it will use its tokens, and then since it's a good LLM, it's asking me that, should I do this action? Can you confirm it? And I say yes. It says it did it. There are some files, and yeah, so when I do a cat, I can see that it does what we want it to do. The interesting thing here is that since I'm the author, I know what best way my tools should be used, and which is why I'm telling the LLM that you have to do these things this way. Okay, now but like creating files is not that fun. Let's take a different example. Okay, so uh, okay, how many of you are familiar with Kubernetes? Just okay. So you don't need to know like full how it works. So let's say we are running a Kubernetes cluster and we deployed 2 workloads, and for some reason both of them are pending. Now I do not know how any of it works. I just know that I can write describe and it will tell me some things. So one thing that it is telling me is did not match some node affinity selector, so it cannot schedule. And then other, it is telling me that insufficient memory, but I do not know what any of this means. So I will ask plot, wait, I hope it opens fast again. Okay, I guess screencast again. Yeah, so cool. So now I have created a prompt called troubleshoot Kubernetes resources. So assume that you don't know anything, but you have somehow access to make the changes. So I'm telling it that troubleshoot all the Kubernetes resource, and then I'm giving it a query that it should be a pod, and its health is unhealthy. Uh, Keep in mind that this is a query that the server will pass, and then we tell it that do this. So yeah, so this is first, so this is a prompt. So the MCP is first asking me, okay, so I need to search your catalog first, what all items do you have? And then only I can like get details about this. So I ask it, yeah, go ahead, run the search. Now it is searching. It found 2 unhealthy pods, as you could see, and it told us that there is some error. Then in our prompt, we have asked it to go deeper, ask for logs if you want, ask for all the change history, and then once you allow everything, it will think, and eventually it told us something that we kind of knew from the description, but now as a user who does not know anything, it is asking me that, okay, remove or modify the node selector for Nginx 1, okay, and then for Nginx 2, it's saying that remove the memory resource, or reduce the memory resource. So let's try if this thing works. So for one, it asked me, okay, there it is. the node selector. Okay, so I remove this. And then if I get pause again, okay. So it helped me fix one bug. And for this, it says, so we are requesting 20 GBs of memory, which is too much. Let's make it 1 GB. And yeah, so other is working as well. So the magic that happened here was I just gave, it's an easy way for me to give an LLM access in a secure way to my system, and then it can help me do things that I might need other people to do. We'll just do a little bit of browsing of how the code works. Uh, just a second. Yeah. So here you could see this is a huge prompt that I've given. So because I know that what all tools are there in the system, so how best the LLM, how best those tools should be used to debug specific issues. And then let's say it called a tool called search catalog. So if you want to see the implementation of the tool called search catalog, uh, we'll go to its handler, and then, yeah, this is like internal logic, but this is basically now any web controller, like how you do for normal functions. So coming back to our presentation, so yeah, but I think none of you would be just developing MCP. A lot of people that I've talked to, they are integrating MCP. Like how I learned all of this is I was integrating MCP into our product. So let's say you have an existing Go web app. So how does this work? Uh, Go has a very interesting thing called interfaces. And one of the most great things, nice things, is that the net HTTP has an interface called serve HTTP, which means that any server, you can write any server, and that is supposed to work with any web framework. So how you create a server would be a new MCP server. Then we are making it a streamable HTTP server because this is HTTP, not local. We can either start the server directly at the port, or let's say if you use Echo or Gin or any other thing, they all have wrap handlers command that accept servers with serve HTTP. So you can wrap that, and all your middlewares and everything else that you have written in your web framework, it will work as expected. So basically, there is out-of-the-box support for MCP. But we're all responsible good devs, so we should also test the code we write. Uh, so testing MCP is not that hard. So we here are creating a client, and then using HTTP test, we created a dummy server, and then the same thing. And how the tests work is, so let's say we are testing the create file. So since we created a client here, we can use that client to call the tool. And the call tool request, you can see the struct, which matches the JSON RPC structure we discussed a while back. So here, what I'm doing is I'm calling the tool. I'm checking if the file exists or not. So first thing is you check the error, you check the result, and then to be extra sure, you check if it created the file in that place or not. And a better way, so this is one way, but an even better way would be to do a end-to-end test. And what you can do is you can start your own LLM or prompt, and then prompt it to create a file, and then check if the file exists or not. Because testing functions is easy, but when you're writing MCP, though it is a bit difficult to predict how LLMs behave, because sometimes even for the same prompt, you can get different results. So security, I'm not sure how much time I have left. So just like the entire tech industry, let's speed run through the security, because why even care? So the do's, these are important. Always check if the user is authorized to call the tools and resources, because the MCP server will probably have a lot of access. So whoever is calling the tool, you should know their, like, first if it's authenticated, and the second if they are allowed to call the tool. And then they, in the specification, it is recommended that you use bearer tokens. And as always with everything, log everything and maintain audit trails, because why not? And the don'ts. These are important because it's really a new technology, and a lot of things are not, like, people are not taking security seriously. One common thing that's been happening is something called token pass-through. So what happens is, I said in my previous slide, use tokens for authentication. But what people do is sometimes the MCP server calls a third-party client. Let's say if I'm using Spotify and I want to create my playlist. What people are doing is they're making their applications in a way that you will pass your Spotify token to the server as well. This is not recommended, because what it can do is it will blur the line between what the user is doing and what the MCP or a proxy of LLM is doing. And then that would break your audit trails. The next is validate and sanitize all the inputs. So I did a wrong thing in my previous example, is that in the create file function, I was just taking the path from the user. I was not checking if which directory I can, like, technically it could have written something to the root directory or like privileged directories, and it would have broken something and I wouldn't know. So always check and validate your inputs. And this is something as a user you should do. So whenever these tools run, they can run bash commands, they can like call web functions, they can do anything. So do not allow all in these cases. Always create a whitelist that the MCP or the LLM should be able to run this. And I guess some bonus tips if you're actually going to build one. So first is to design around intent, not API endpoint. What it means is, let's say we have, like, I want to add a user to a team. So when I think of it in API endpoints, let's say the users are A and B, I will fetch all the users, I will get the user ID of user A and B, and then I'll make a post call to add user to team, and I'll then pass on the IDs. But if you're building an MCP and this is your function, you should not, like the user writing the prompts, they should not be calling 5 different functions. For them, the only thing that should be exposed is add users to the team, and then the MCP should figure out what to do, how to get that data, and how to add them. The descriptions and responses that the server returns are very important, because that is the only way you can tell an LLM how to, like, what to do and when what works. So for example, the troubleshooting prompt that I just showed you, it tells the LLM that this is for troubleshooting Kubernetes resources. So if I ask that this is not working, what can I do? It will know to help you. And as and similarly, whatever the error your server returns, that is also very helpful for LLM. So you not only are writing these things for the end user, you are also writing these things for an LLM. And as always, it's rapidly growing. Like 1 year ago, 2 years ago, this didn't even exist, and now we have a lot of things built around it. So lastly, I want to end on something philosophical. Like, we all have been using a lot of AI tools, and it's kind of blurring the line between what is the role of humans and what's the role of AIs. But you should always remember that, like, AI is just another tool, and it is what you do, what we do, that makes us human. And as the great poet Alexander Pope said, to err is human, and handling error is what makes us go first. So thank you.